Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video, we're going to be looking at the quotient rule. So by the end of this lesson, you'll be able to explain what the quotient rule is, know when to use it, and actually use it. So what is the quotient rule? Well, suppose you have a function y equals u over v is the quotient of two functions u and v, each of which is a function of x. So what that means is, in the numerator, that is a function in terms of x, and in the denominator, that's also a function in terms of x. So if we want to find the gradient function, or if we want to differentiate this, then dy dx is equal to v times du dx minus u times dv dx all over v squared. Or what I like to use, y dash is equal to vu dash minus uv dash over v squared. I like to use this because it's similar to the product rule, where for the product rule, where y dash is equal to vu dash plus uv dash. Okay, so the only difference is instead of minus, it's a plus, and there's no v squared at the bottom. But our reference sheet uses this one, so I'll show it to you. Here's our reference sheet. If we were to scroll down to the differential calculus, here it is, y equals u on v. It gives you the first one. dy dx is equal to v du dx minus u times dv dx all over v squared. I prefer if you just memorize the second one that I've highlighted here. So here's an example. If y is equal to 3x over 5x plus 2 all to the power of 4, then u is equal to the top, the numerator, and v is equal to bottom, the denominator. So when do we use the quotient rule? We use the quotient rule when both u and v are in terms of x. So here in question A, f of x is equal to 7x minus 3 all over 4x squared. We can see the numerator has an x in it. The denominator also has an x in it. So yes, we use the quotient rule. Question B. Oh, the numerator doesn't have an x in it. The denominator does. So no, we don't use quotient rule. You might be thinking, oh, so what rule do we use then? Well, we can rewrite this question as y equals 12 lots of 3x to the power of 4 plus 1 to the power of negative 3. So we have to use the chain rule. Use chain rule instead. Question C. Numerator has an x, denominator has an x. Yes, we use the quotient rule. Yes, use the quotient rule. Okay, so if we scroll back up to the top, we can see here the numerator has an x, denominator has an x. So yes, we use the quotient rule. Okay, so let's actually use it. Question A, we've got y equals 2x plus 1 over 2x minus 1. So u is the top, 2x plus 1, and v is the denominator, 2x minus 1. So we want to differentiate each of these with respect to x. So when we differentiate this, we just get 2. When we differentiate this, we also get 2. So y dash is equal to vu dash, let's write it down, minus uv dash all over v squared, which in this case is vu dash, so we're going to times these two together. So we've got 2 lots of 2x minus 1, and then we're going to minus uv dash, we're going to times these two together. 2 lots of 2x plus 1. All over v squared. 2x minus 1 squared. Now, whenever we want to simplify this, we always want to simplify the numerator. We never need to expand the brackets in the denominator, just leave that as it is. But the numerator, we do need to simplify. So I'm going to expand the brackets. We've got 4x minus 2 minus 4x minus 2 all over 2x minus 1 squared. And that's equal to negative 4 all over 2x minus 1 squared. And that's it. Why don't you pause the video, have a go at question B by yourselves. Okay, question B, u is equal to x and v is equal to x squared plus 1. So u dash is equal to 1, v dash is equal to 2x. So y dash is equal to v u dash. I'm going to times these two together, which is just x squared plus 1. And then a minus u v dash. I'm going to times them together. That gives me 2x squared all over v squared. This gives me negative x squared plus 1 all over x squared plus 1 squared. Okay. Let's have a look at question C and D. Question C. F of x is equal to 3x minus 5 over 5x plus 2. So u is equal to 3x minus 5. V is equal to 5x plus 2. U dash is equal to 3. V dash is equal to 5. So f dash of x is equal to, how about I get you to pause the video and have a go yourself? Okay, let's go through this. Vu dash, 3 lots of 5x plus 2, minus uv dash, which is 5 lots of 3x minus 5, all over v squared. So that gives me 15x plus 6 minus 15x plus 25 all over 5x plus 2 squared. And that simplifies to 31 over 5x plus 2 all squared. Okay, question D is a little bit more tricky. So we've got u is equal to 2x minus 9 cubed, and we've got v is equal to 5x plus 1. So u dash, we need to realize that we need to use the chain rule here. When we differentiate this, we bring down the power, reduce the power by 1, but we still need to times it by the derivative of what's inside the brackets, which is 2. Okay, so when we differentiate that, we get 2. So 3 times 2 is just 6. So we've got 6 lots of 2x minus 9 squared. V dash is 5. And so now we can actually work this out. We've got not f dash of x, we're going to use y dash because we've got y here, is equal to vu dash. So I'm going to times this one and this one. That's going to give me 6 2x minus 9 squared 5x plus 1. We're going to minus uv dash. That's 5 lots of 2x minus 9 cubed all over v squared 5x plus 1 squared. Now I'm not going to expand the brackets here. What I'm going to do instead is I'm going to factorize out a common factor. I can see that in the numerator that they both have 2x minus 9 squared. This one has cubed, so common factor will be squared. So I'm going to factorize that out. 2x minus 9 squared. What's left over is 6 lots of 5x plus 1 minus 5 lots of 2x minus 9, because there's still one lot of that. All over 5x plus 1 squared. Let's expand the what's in the square brackets. So we've got 30x plus 6 minus 10x plus 45 all over 5x plus 1 squared. And now we can tidy this up. 2x minus 9 squared. We've got 20x plus 51 all over 5x plus 1 squared. Okay. These two are probably the two hardest questions in this video. Question E. We've got u is equal to x minus 1 to the power of half, and we've got v over here is equal to 7x plus 2 to the power of 4. So u dash is going to equal to half x minus 1 to the power of negative half times the derivative of what's inside the brackets, because we need to use the chain rule. But when we differentiate that, we just get 1. So we times it by 1, so it's just itself. V dash is equal to 4 brackets 7x plus 2 cubed. Again, we need to use the chain rule times the derivative of what's inside the brackets, which is 7. And that gives us 28 brackets 7x plus 2 cubed. Now for u dash, I might just want to, well actually, when we write this out, let's write this out. When we differentiate this, we get y dash is equal to vu dash. So I'm going to be timesing these two together. Except this power negative half, I'm just going to put it in a denominator as in third form. So we've got 7x plus 2 to the power of 4 all over 2 lots of the square root of x minus 1. Okay, so I just wrote that at the bottom. Okay, 2 at the bottom. This goes to the bottom as well. We're going to minus uv dash. These two multiply together, which is 28 7x plus 2 cubed. I'm going to write this in third form, the square root of x minus 1. And all of that over v squared, which is 7x plus 2 to the power of 8. Okay, so you might think, oh, this is starting to look a little bit ugly. Yep, but it's going to help us out. So in the numerator, we've got a fraction minus all of this. So what I'm going to do is I want to make them have a common denominator. So I'm going to multiply both, I'm going to multiply the right hand side by 2 lots of root x minus 1. So that leaves me with 7x plus 2 to the power of 4 minus 28 times 2 is 56. Lots of 7x plus 2 cubed. And then we've got root x minus 1 times root x minus 1, which is just x minus 1. Now that is all over 2 root x minus 1. And then that's all over 7x plus 2 to the power of 8. However, what we can do is, we can move this down here. And that's exactly what I want to do, just to make it neater. So I'm going to get rid of that. I'm going to have my 2 root x minus 1 with my 7x plus 2 to the power of 8. Now we can only do that when we've got the common denominator for both terms. Okay, if we have a look at just this line, only the left term has that denominator and the right one doesn't, so we can't just bring it down yet. We need to make both of them have the common denominator, and then we can bring it down. Okay, now I will factorize out a common factor. I can see that they both have 7x plus 2 cubed. That's the smallest one. So if I bring that out, I've got 7x plus 2 cubed. What's left over is 7x plus 2 from the first term, minus 56 lots of x minus 1 in the second term, all over 2 root x minus 1, 7x plus 2 to the power of 8. I can see that I can cancel out this and 3 of them over here, leaving me with 5. So I'm just going to do that, and then I'm going to expand the brackets and simplify. So in the numerator we've got 7x plus 2 minus 56x plus 56 all over 2 root x minus 1 times 7x plus 2 to the power of 5. Okay, let's simplify this. 7x minus 56x is minus 49x. 2 plus 56 is 58. All over 2 root x minus 1, 7x plus 2 to the power of 5. Okay, so that's it for E. Why don't you pause the video, have a go with F, it's very similar. Okay, let's have a look at question F. So question F here, we've got f of x is equal to root x squared plus 1 over x minus 9 squared. So u is equal to x squared plus 1 to the power of half, and v is equal to x minus 9 squared. So u dash, bring down the power, x squared plus 1 minus power by 1, but we need to times it by the derivative of what's inside the brackets because we need to use the chain rule. And when we differentiate that with respect to x, we get 2x. So I'll just tidy this up. Half times 2x is just x. And I'm going to rewrite this as the square root of x squared plus 1. So let's just put this in the middle. Okay, and v dash, bring down the power, reduce the power by 1, times by the derivative of what's inside the brackets, which is just 1, so that's it. Okay, so f dash of x is therefore equal to vu dash x times x minus 9 all squared all over the square root of x squared plus 1 minus uv dash 2x minus 9 the square root of x squared plus 1 all over v squared x minus 9 to the power of 4. Okay, so now we want our common denominator. So we've got x minus 9 squared. I'm going to multiply the right hand side by root x squared plus 1. So that leaves me with 2 bracket x minus 9 bracket, well, root x squared plus 1 times root x squared plus 1 is just x squared plus 1. And then I'm going to bring my common denominator of root x squared plus 1 to the very bottom with my x minus 9 to the power 4. Okay, I'm going to factorize out my x minus 9. That leaves me with x lots of x minus 9 in the first term, minus 2 lots of x squared plus 1 in the second term, all over root x squared plus 1 times x minus 9 to the power 4. I'll now expand. We've got x squared minus 9x minus 2x squared minus 2. And that simplifies to x minus 9 negative x squared minus 9x minus 2 all over root x squared plus 1 x minus 9 to the power of 4. Except we can see here that the x minus 9, that can cancel with this. So let's just do that. Let's get rid of this and make it a cubed, which means we don't need the brackets at the top. And I might just move that to the middle. Right there. Okay. So that's question F. And question G will end with an easier one. We've got y is equal to 4x cubed minus 5x plus 2 all over x cubed minus 1. So we can see here that u is equal to 4x cubed minus 5x plus 2. V is equal to x cubed minus 1. So u dash is 12x squared minus 5. And v dash is equal to 3x squared. So y dash is equal to vu dash minus uv dash all over v squared. Let's expand the brackets. So that leaves us with 12x to the power 5 minus 5x cubed minus 12x squared plus 5 minus 12x to the power 5 plus 15x cubed minus 6x squared all over x cubed minus 1 squared. And so our final answer, that cancels. Minus 5x cubed plus 15x cubed is 10x cubed. Minus 12x squared minus 6x squared is minus 18x squared plus 5 all over x cubed minus 1 squared. And that's it for this video.